Hey, it's Horner, and this is problem number 8. We have a drop of water on a leaf, so there's that drop of water. It falls from rest. So one of the things we need to recognize here is that the original speed is equal to 0 meters per second. And it travels this entire distance until it hits the ground. If the bottom half, it falls and it takes 1 second, they want to know what is the total time to fall, the initial height of the drop, and then they want to know why does only one of the answers for part A make sense, even though they're both mathematically correct. So the very first thing we need to do is think about that drop. So we know that drop at the top is 0 meters per second. That's the speed. So it's not really a ball, I guess it's being dropped. It is a drop of water. So the drop of water is up here. We let go of it and its original speed is 0. So we need an equation to help us figure out what is the total time. So that would be both t1 and t2. So the total time to fall. That equation is this one. So it's the same as the delta y, or delta x, is equal to original speed times time plus 1/2. And instead of acceleration, we're going to do gravity here, times time squared. Well, we said our original velocity is 0. So now we can use equation 1. So we're just making equation 1. And we get rid of this term, so we just have 1/2 of gravity times time squared total. Equation 2 will be for this little bit of time down here. So what I'm going to do is I'm going to say for height number 2, it's the total time minus the total time minus 1 second squared. I'm going to set these two equations equal to each other because you'll notice for equation 2, I can get rid of all the 2's on the bottom, and now I have two equations for h. Now I'm going to set those equal to each other. So I've got this equation 2 is also right there. And I want to set the two equal to each other. So that's what we're going to do. Right here I've got 1/2 gt squared. So that's the equation 1. Equation 2 is gt squared minus gravity times t minus 1 squared. I can cross off gravity all the way across, and then when I get down here, I notice I have t2 minus t1. So don't cross them off, but they just totally disappear because that minus that is going to be 0. So now we're left with 1/2 t squared is equal to 2t minus 1, and I can rearrange this into a quadratic, and then what I did is I just typed into Google quadratic equation solver, and I put that equation in, and it actually solved it for me. So now I don't have to worry about doing that, but you can totally do that in your calculator. And you'll see you get two answers. The radical 2 answers are not going to be anything that you're going to want to deal with, so definitely do this. And we've got 2 answers, but only one of those 2 answers makes sense. The 0.586 is only half a second. And if you're dropping it from a cliff, it's probably going to take longer than that. Or if it's coming from a tall tree, it definitely is going to take more time. So 3.414 seconds sounds much better. That is the answer to letter C. And the answer to letter B is, what is the height then of that leaf where the drop falls? So we now know the total time is 3.414. So we're going to put in 1/2 of gravity. Don't have to worry about negative or positive here because we're just dealing with height. And then times that speed of 3.414 squared. And we get 57.1 meters. Let's go ahead and take a look at the next two. They're much easier. This is number 9. All right, here comes number 9. So we've got a rock thrown vertically upward from ground level at time 0. At 1.5 seconds, it gets past the top of a tall tower, and 1 second after that, it reaches the maximum height. So one of the things you'll notice right off the bat here is the total time of travel is 2.5 seconds. And so we've got that over here. At the very top, this rock has a speed of 0 meters per second. And you'll notice that if that's true, then what we can do is we can say the final speed at the top is equal to the original speed at the very bottom times plus gravity times time. So now what we can do is we can say 0 is equal to the original speed minus 9.8 times 2.5. We'll move the VO to the other side. Now they're both negative, so we can get rid of the negatives. And your answer here is just 24.5 meters per second. So right here, at the very bottom, it's going 24.5 meters per second. Now that we know how fast it's going up, we can use our distance equation, delta y, and sometimes this is delta x, is equal to VOT plus 1/2 gravity times time squared. We've got 24.5 times 1.5, and notice that this is up. So we want to define up here as positive and down as negative. And because gravity is down, we're going to make it negative 9.8. And that's really important here because you'll notice that you'll end up subtracting 11.025 instead of adding it. So now we have 36.75 minus 11.025, and that gives us 25.73 meters. For the very last problem, we have a boat, and the boat starts right here. So this is the starting point, and then right here is kind of the end, but it's still moving. So it's just going along at a constant speed, and this key falls from somebody's hand, and it lands in the boat. So when they release the key, the boat is over here. So this is time is equal to 0, and this is time is equal to 0. Then that falls, and the boat is traveling, and this is the final time, and the key falls down and goes in the boat, and that is also the final time. So we know that once we drop this as the boat's moving, then it goes under the bridge, and that falls directly down into the boat. So the height we know of this bridge, and we know the original speed of the key at the very top is 0. So that's the original speed of the key. And we can then, I got to put a plus in here, add to that 1/2 of gravity times time squared. And because we know that it's moving down, let's make down positive this time, and up is negative. Since we're measuring from the top down, and that's 45, we'll make it positive. And because gravity is down, and we said down is positive, we'll make that positive. So that's just plus 1/2 gravity times time squared. Now we can solve for time, and we find out it takes 3.03 seconds for it to fall down here, which means it also takes 3.03 seconds, 3.03 seconds for the boat to travel from here to here. And if we want to find the speed of the boat, we just take the distance that the boat traveled and divide it by the time, 12 divided by 3, and we get 3.96 meters per second. And that is the last one.